So today we are going to start our very first lesson. It's chapter P, which stands for the prerequisite chapter, and we're starting with section 2. Now, we're skipping over section 1, and in section 1, I'll go ahead and give you a PDF of the chapter if you choose to read it. But in section 1, it talks about real numbers, it talks about integers, all the different types of numbers that you've probably seen over and over again in your pre-algebra classes and in your algebra classes. It also talks about expressions, what a term is, coefficient, just your basic rules. So we are skipping over it, but if you choose to read it, you can. We will not be testing you on what type of number is the number 5. Is it an integer? Is it a real number? Is it a whole number? Things like that. That's what's found in section 1. So we're going to talk about today exponents. Now we are going to be splitting up section 2 into 3 different days. We're going to be, I have named it as P2A, P2B, P2C. But today what we're going to focus on are integer exponents. So when you have an exponent, it just means that it's a shortened way of writing the repeated multiplication. So for example, if you have a to the 5th, all that really means is you're going to take a and you're going to repeatedly multiply a 5 times. So the power tells you how many times you're going to multiply something. And then the next one. Now, when you have in these integer exponents, this number that's here at the bottom, the larger number, this is called the base. And up here, this is your power or your exponent. Now, when you have a negative number, that is your base, you need to be very careful. Because, for example, if you have an even exponent or an even power on a negative number, and if that negative number is in parentheses, really what this means is you're multiplying negative 2 times negative 2 times negative 2 times negative 2. Now, when it's an even exponent, and if that negative number is in parentheses, your answer is going to end up being positive because you can either choose to take this negative 2 times negative 2, positive 4, and then if you do it again times the negative 2, then you get negative 8, but then once you do it again times this one and you multiply it, it becomes a positive 16. However, if there is no parentheses around that negative number, what's being raised to the 4th power is only the 2, not the negative sign. Some people like to think of this as being a negative 1 times a 2 to the 4th, or a lot of times I just think, okay, the negative sign is not being held in the parentheses, so it's going to fall down in front of the answer. Or again, you could do 2 to the 4th, which is going to be 2, 2, 2, 2, which is going to give you 16, and then 16 times negative 1, and the answer is negative 16. So be very careful when the base is negative and if it's in a parenthesis or not, okay? If it's raised to an odd power, it's still going to be a negative number. So for example, on this one that was right here, the negative 4 to the 3rd power, whether it's in parentheses or not, and when the power is odd, it's still going to be negative because this means negative 4, negative 4, negative 4. And if you multiply this, it turns positive 16. But then when you multiply it again to a negative 4, it turns negative. So when the power is an odd number, it's still going to be negative. Same thing here. If you were to think of this as a negative 1 times 4 to the 3rd, it's negative 1 and then 4, 4, 4. It ends up being negative 1 times positive 64. And then once you multiply, it's still negative. So it's only when that power is even and if that base is negative, stop and think before you do it. Now, the next example here is 2x to the 4th power. That power of 4 not only goes on the x, it's also on the 2. So the repeated multiplication here, once you multiply this, you would have to multiply all the 2's. So this would actually turn into 16 and then x to the 4th. But we're going to see coming up what happens when you multiply variables that have exponents. So when you have something and it's written with an exponent, exponential notation, if a is a real number and n is a positive integer, then a to the n power just means you're going to multiply a n times, where n is the exponent and a is the base. So a to the n power here is read to a to the power of n or a to the nth power. So for example, again, let me do it with some numbers instead of letters. Let's say I have 2 to the 3rd power, or 2 to the power of 3. As a repeated multiplication, this means 2 times 2 times 2. And if I ask you to simplify it, you need to multiply that. 2 times 2 is 4, times 2 again, and it's 8. So the 2 here is the base, and the 3 is the exponent. Next, we're going to talk about multiplying exponential expressions. So when you have the same base, you're going to add the exponents. So in this case, in this particular example, we have the same base. They both have a base of a. And then we're going to take those two exponents and add them. There's another example here where we both have a base of x. And then we take the two powers, 3 and 4, those exponents, and add them. Let's say we have a base that's a number. Let's say we're going to multiply 2 to the 3rd times 2 to the 4th. So notice both of the bases are the same. They're both 2's. So you leave the base. You never multiply those bases. And then we're just going to take the two exponents. We're going to add them. And it becomes 2 to the 7th. Now, if it asks you to just leave it in exponential form, then we would leave it as 2 to the 7th. But on your quiz, you're going to actually figure out, without a calculator, what 2 to the 7th power is. So you would have to multiply 2, and we're going to write 2 7 times. And then we'll start multiplying. Now you could go, one by one. 2 times 2 is 4, times 2 is 8. If you prefer to say, okay, I'm going to do these two and make it a 4, these two make it a 4. Again, it really doesn't matter. Multiplication is commutative, so you can multiply this any way you want. This guy still didn't get multiplied. And then if you want to do these two and make it 16, and if you want to do these two and make it an 8, and then finally do 128. If you would have preferred to do 2 times 2 is 4, times 2, 8, times 2, 16, 32, 64, and then finally 128. You can do it that way as well. So again, just remember multiplication is commutative. Remember, you do not multiply the bases. You keep the base the same. Now, if I give you a problem where the bases are different, let's say it was 2 to the 3rd times 3 squared, I can't just add these powers. I would have to figure out what each one is individually and then multiply those answers. So for example, I would do 2 to the 3rd. That would have been 2 times 2 times 2, which is 8. And then 3 to the 2nd, or 3 squared, would be 9. And then I would multiply and get 72. So when the bases are different, you just have to figure it out individually. So when the bases, so these big numbers here, if they're not the same, then you just have to follow order of operations basically, and you're just going to figure out what 2 to the 3rd power is. So you would do 2 times 2 times 2, and that would give you 8. And then you would figure out what 3 times 3 is, or 3 squared, and that would give you the 9. And then you would just multiply 8 times 9 and get 72. So you can't use this property here of when the bases are the same. You just have to do it by hand. Okay, so it says to simplify the expressions. So the first thing we're going to do is when we see a problem that's got some exponents in it, we're going to check to see, are the bases the same? If they are, then all we have to do is take their exponents. So b to the 7th times b to the 4th really just becomes b raised to the 7 plus 4 power, and this would be b to the 11th. We don't know what b is, so we would just leave it there with the variable. Now, when there is a coefficient, a number in front of your variable, we are going to multiply those coefficients, but we add the powers on we add the exponents on the variables. So here what I'm going to do is I'm going to take my coefficients. My coefficients are the 3 and the 4. I'm going to multiply them. So 3 times 4 is 12. And then for the x, the variable x, I'm going to add those powers. So this would become x to the 2 plus 3, so x to the 5th. The next one is the same thing. Now we're applying our rules for integers here. Remember, a negative times a negative is a positive, or a positive times a positive is a positive. But when the signs are different, a negative and a positive, the answer is negative. So negative 3 times positive 4, these coefficients are going to multiply together, and I get negative 12. And then I take the variables, and because the variables have the same base, they both have an x, I'm going to take those exponents and add them. 2 plus 4, and I get x to the 6th. So don't get confused that you have to multiply the exponents, you add the exponents. Same thing on D, I'm going to multiply my coefficients. Negative 3 times positive 5 gives me negative 15. Now I'm going to go back and I'm going to look for my like bases. So I have an A here and an A here. Notice on the 5A, b to the 4th, A doesn't have a power. It's got an assumed power of 1. So when I go back to add those, I'm adding 3 and 1. So A becomes to an exponent of 4. And then when I go to do the B, both of those B's have exponents. So I add 2 plus 4, and it's b to the 6th. So whenever you have a variable, and if it doesn't have an exponent that you can see, always assume that it has a power of 1 or an exponent of 1. Same thing on example E. We're going to assume or know that there is a power of 1 here on this n and this m. So when I go back to look for my like bases, I have an m squared multiplied to an m to the 1st. So this will become m to the 3rd, and then n to the 1st, n to the 4th, and I get n to the 5th. I'm adding 1 plus 4. On the next one, I'm going to go ahead and multiply my coefficients, the 3 and the 4. 3 times 4 is 12. I'm going to go back and look for my like bases. I have a y to the 3rd and a y to the 4th. I'm going to add 3 plus 4, and it becomes y to the 7th. And then z, again, this z has got an assumed power of 1. And then z squared, I'm going to add 1 plus 2, and it becomes z to the 3rd. Generally, when I've got more than one letter in my answer, I always like to try to write my answers alphabetically. Technically, this answer could also be 12z to the 3rd, y to the 7th. I like to consistently whenever I'm trying to combine like terms or multiply or add, and I've got more than one variable going on, I always try to like to put them alphabetically. It helps me to look for like terms a little bit easier. So again, technically, the order of the variables doesn't matter, but most of the time on a standardized test or a test, you're going to see it in alphabetical order, ABC order. All right, still some more examples. This time we have 3 terms, but we're still doing exactly the same thing. Now, if you want to think of this first term as really having a coefficient of a -1, x squared y to the third, you can. So then what I'm going to do is multiply my coefficients, the -1, the +3, and the -2. So when I go to multiply that, -1 times +3 is -3, but then when I multiply it with the -2, it becomes +6. Now I'm going to go back, look for my like bases. I have an x squared, an x, I can assume it's got a exponent of 1, and then x to the third. So I'm going to add 2 plus 1 plus 3, which gives me x to the 6th power. Then I'll go back and look for my like bases. I've got a bunch of y's here. And again, this y has a power of 1. So 3 plus 2 plus 1, and we get y to the 6th. And we're done. Technically, we could write it as 6y to the 6th, x to the 6th. But again, I like to write it alphabetically, ABC order. A little trick you can do is, if you don't want to worry about the negative signs in front, if you count however many negative signs you have in all your terms, whenever it's an even number of negative signs, the answer will be positive. If it's an odd number, then it's negative. So here I'm going to multiply my coefficients. So I have a 5, -3, and again, if you want to think of this as a -1, a to the third, you can. So then this becomes a +15. And then now I'm going to go back and look for my like bases. So the first term doesn't have an a, but the second one does, and so does the third one. And again, I'm going to add those exponents, 2 plus 3, and I get a to the 5th. And then now I'll go back and find all of my terms that have the b to the 4th, and again, this one has an assumed 1, so it becomes b to the 5th. And again, technically, you could have also written it as b to the 5th, a to the 5th. The order of the variables doesn't matter, but again, I always like to put it in alphabetical order. Now, what I was saying about the even and odd business, so for example, let's say I have, without any variables, just showing you what I mean by when there's an even number of negative signs, your answer is going to be positive. I'll show you what I mean by that. So let's say I'm going to multiply -1, -1, -1, and -2. So if I count the negative signs, I've got 1, 2, 3, 4 negative signs. 4 is an even number. So without even worrying about the signs, I could just multiply now 1, 1, 1, and 2, and the answer will be positive because 4 is an even number. If I would have had -1, -1, -1, and then now +2, notice there are 3 negative signs. 3 is an odd number, so this tells me my answer is going to be negative. So that's a little trick. Instead of having to say, I'm going to do -1 times -1, which gives me +1, then bring down these two, keep multiplying, then this turns -1, and then -2. If you want to just ignore the negative signs when you're doing the multiplication and just count them, it's a little trick to confirm that you've done it correctly. So an odd number of negative signs makes it negative. An even number of negative signs makes it positive. All right, more examples. Now, you have to follow order of operations, PEMDAS. So we always would do parentheses first, then exponents, then multiply, then divide, then add or subtract. So in this particular problem, I need to simplify this exponent first. So what I need to do here is negative x times negative x, which is going to give me a positive x squared, because I assume a 1. And then now I can multiply it, because the first one was already simplified, and now a negative times a positive is a negative, and then you add the 2 plus 2. Same thing on the next one. This is going to become really negative x, which will become negative x to the third. And then bring this one down, because it's already inside it. And now I'm going to multiply a negative times a negative, becomes positive, and then add 3 plus 3. Always, always, always follow order of operations, and then do whatever you have to do next. So I did the exponent first, and then I went back and I multiplied. More examples. So again, I'm following order of operations. So I'm going to go ahead and multiply before I add. So I'm going to multiply this term, these two terms, and then these. So for the first one, I multiply the coefficients. 5 times 2 is 10. And then the x's, I'm going to add those exponents. 2 plus 3, I get 5. Then I'll do the other term here. 3 times 4 is 12. And then again, this x has an assumed 1, so it becomes x to the 5th. And now I need to look at my terms, and I can see that they have exactly the same variable. So they're actually like terms, so I can add the coefficients. So now I'm going to add 10 and 12, and then I get 22 x to the 5th. When you add like terms, you do not add exponents. You only add the coefficients. Now, let's say I did this problem, and let's say the answer became 10x to the 5th and 12x to the 4th. That would be in simplest form. These are not like terms, so I would have left that one alone. So the only time I can combine terms is when they're like terms and they have exactly the same variable with exactly the same exponent. The next one is a subtraction problem. So again, I'm going to do the same thing. I'm going to multiply each one first, and then I'm going to subtract if they're like terms. So for the first one, I'm going to multiply the 3 and the 5, and then add the powers or the exponents on those a's. 5 plus 3, I get 8. Then I'm going to do the next one. Again, it's 6, and again, you can assume there's a 1 in front of that a to the 6, so it just becomes 6. And then I add 2 plus 6, and I get 8. Again, I got like terms. And again, when I combine like terms, I'm just working with the coefficients. So 15 minus 6, and I get 9a to the 8th. Or a new rule. Next one is called raising a power to a power. So whenever you have a power raised to another power, we're going to multiply the exponents. So in this particular example, we have a to the m raised to the n power. We take that power or that exponent of m and multiply it to the n. Same thing on this one. This power of m or exponent needs to go to both. And that's why it becomes a to the m, b to the m. Here's an example with an x. I just take the 4 and the 5 and I multiply them. So for example, let's do another one. Let's say it's x squared raised to an exponent of 3. I take those two exponents and I'm going to multiply them. So this would give me x to the 6th. Now, before I move on to the next slide, I want to just review a few other skills that you should memorize. Now, whenever you have a power of 0, so a 0 power, any number raised to the 0 power equals 1. You need to memorize that. Even if it's 1,000 raised to the 0 power, the answer is 1. Now, you do have to be careful with negative numbers. So, for example, if I have -1 in parentheses to the 0 power, this equals 1. However, if I have a -1 raised to the 0 power without a parenthesis, remember this power of 0 is only on the 1, not on that negative sign. Again, you can think of it as a -1 times 1 to the 0, which then would become -1 times 1, and this gives you a -1. So be very, very careful when you have a negative base and it's raised to a power. Check for those parentheses. If there's no parentheses holding in that negative sign, your answer is going to be negative. Think of this negative sign as just falling down because there's nothing holding it in, and then you evaluate that part. Wanted to show you that anything to the 0 power is 1, unless it's a negative base, then look for the parentheses. Let's try some more examples. All right, so here we have a term that's raised to the 3rd power. Remember, this exponent of 3 needs to go on the 2 and to the x. So you can think of this as two different ways. You could either say, I'm going to think of it as 2 to the 3rd, and then x to the 3rd, and then do 2 to the 3rd, which is 8, and then x to the 3rd. Or you could also think of it as doing 2x times 2x times 2x, and then you use your rule for multiplying. Multiply the coefficients. So the 2, and the 2 get multiplied. 2 times 2, 4 times 2 again, 8. And then remember, all these x's have a 1, and then add them and still get the same answer. For part B here, we're going to, again, that power of 2 needs to go to the 2 and to the x to the 5th power. So again, you can either think of it as 2 squared, and then remember, power to the power, we're going to take that and multiply it. So 2 squared is 4, and then it becomes x to the 10th. Again, if you prefer to think of it as x to the 5th times x to the 5th, you can do it that way. And then multiply the 2's, and then add the powers on the x's. And you get the same answer either way. Next one, same thing. This power of 2, it's going to square that negative number. So it becomes -2 squared, and then here 5 times 2. So it becomes positive 4 x to the 10th. So when you have parentheses around a negative base, if the power is even, your answer is going to turn positive. Notice this next one, D, that exponent is an odd number, and it's got a negative base there, so my answer is going to be negative. So again, if you'd rather think of this as, you could do it as -2 to the 3rd, and then x to the 4 times 3. This gives me -8 x to the 12th. Or again, think of it as -2 x to the 4th, and write it down 3 times, and then go back and multiply it like we did at the beginning. Either way, it's still going to give you -8x to the 12th. For the next one, Again, this power of 3 or the exponent is going to go to the -3, to the x, and to the y. So it'll become -3 to the third, x squared, and again, power to a power, we're going to multiply the exponents. So -3 to the third, -3 times -3 is +9, times another -3 gives me -27. Multiply those powers on the x, and also multiply the exponents on the y. Now this next one is already simplified. So if they ever give you something like this and they ask you to simplify, if it's already simplified, you could just rewrite the problem. But let's modify this a little. Let's say f was really -x y squared raised to a exponent of 2. So again, this 2, if you want to think of it like this, you can write it twice. Again, that base is negative, but the power is even. So this is going to turn positive, and these x's have an assumed 1. So this will become x squared. This one needs a 2 here, not outside. And then add the y's. All right, 3 more on this slide and then a few more on the next. So again, you're going to take care of each term first. So we're going to take care of that exponent first. We're following PEMDAS. So again, this power or this exponent needs to go to the 3, to the a, and to the b. So this will give me 27, a to the 6th, b to the 3rd. Now I'll take the next one. Take that exponent of 2, goes to the 2, to the a, and to the b. So this becomes 4, a to the 6th, b to the 2nd. Now when you multiply, you don't need like terms. Remember, we're just going to add those exponents, but we're going to multiply the coefficients. So I actually have to multiply 27 times 4. This is going to give me 108. And then I'm going to go back. I'm going to add the base a's. 6 plus 6 is 12. And then go back and get the b's. And then b to the 3rd and b squared. 3 plus 2 is 5. Same thing on the next one. Take care of each term first and then go back and multiply. So that power or that exponent of 4 goes to the 2, to the x, and to the y. So 2 to the 4th is 16. X squared raised to the 4th, multiply it, get an 8. And then y to the 12th. That's the first term. Second one, it's an even exponent, so this is going to become positive. So x squared, y to the 4th. And now I can multiply the two terms. 16, remember you add the powers now. X to the 10th and y to the 16th. For the next one, I need to figure out this one, and then I'll multiply it. So this will become that exponent of 3 goes to the 2 and to the x. So this becomes 8x to the 3rd. And then this one becomes x squared, y squared. Over here, there was nothing to apply, so I could just rewrite this one for now. And now I'm going to multiply each one. So again, coefficient here is assumed to be a 1, so it just gives me an 8. Add the powers on the exponents on the x's. And then over here, same thing. You could assume that this is a -1. So then this becomes a -4. And then x to the 5th, y to the 2nd. Now, if you would have rather just written this as x to the 5th, y squared, minus, because that 4 was negative, you can do that. These are like terms. the x and the y have exactly the same exponent. So now I'm just going to subtract the coefficients. And I'm done. Last slide. All right, so here, if it's a fraction, this power of 3 goes to the numerator and the denominator. You could write this 3 times if that helps you. But I'm going to be doing 3 to the third, which is 27. And then x becomes to the third. Then for the denominator, that 2 gets raised to the exponent of 3, so it's 8, y to the third. And I'm done. If I would have had a fraction that I could simplify, I would have. Now, here again, notice this is a negative base. So again, think of this as being a negative 1 times 4 squared, which is really negative 1 times 16. And I get negative 16. Over here, if you want to think of this as negative 1 times 4 times 4 times 4 gives me negative 64. This one is really negative 4 because it's in parentheses and it's positive. And the last example is a 1.